Hello, everyone. Welcome to another exciting session of NextGen 23, the industry's largest drone autonomy summit. Audience, before we begin, it would be great if you could let us know where you're joining from, what do you do, and what excited you about this session. Today, we will be exploring the exciting and rapidly evolving world of unmanned traffic management, UTM, and its role in shaping the future of automated skies. With the drones being increasingly used for both commercial and personal purposes, the need for safe and efficient management of air traffic has become more critical than ever before. We'll explore the benefits and challenges of UTM and its potential to revolutionize how we use drones in our daily lives. To discuss the exciting potential of unmanned aerial systems, I would like to welcome to the stage Philip Binks, Head of Air Traffic Management at Altitude Angel. With over 20 years of experience in aviation, Philip has a deep understanding of ATM and airspace and a wealth of knowledge on integrating drones safely into our airspace. Prior to joining Altitude Angel, he worked as an remote pilot RPAS domain expert and solution architect at NATS, where he played a pivotal role in several high-profile programs, including the UK's Pathfinder program and the ICOA RPAS panel. With his extensive background and unrivaled expertise, Philip is a true leader in field of drone air traffic management, and we are thrilled to have him as our guest speaker today. Before I pass it on to Phil, I would like to share a few housekeeping rules. Please type in your questions in the Q&A tab of the session, and it will be answered at the end of the presentation. The session is getting recorded and will be published soon. We also have an Altitude Angel booth in the expo. Please make sure you visit it. Finally, please remember to capture your favorite moment of the session and share it on Twitter and LinkedIn by using hashtag NextGen23 and tagging Flightbase. Few lucky people who share might have a surprise in store. There's an ongoing poll during the session. Please participate. I would also like to thank DJI, our title sponsor, and Volatus, platinum sponsor, for their support. With that, over to you, Phil.
Oh yeah, good afternoon or good morning, good evening, wherever you are in the world. Thank you very much for inviting me to come along today. If you just wait a second, I just need to share a screen or share my presentation, and we'll get on with the presentation. So stand by one moment. As people tell you who I work with, I'm absolutely rubbish with technology. Thank goodness I have a great set of great team here at Altitude Angel that's supporting everything I do. Look, thank you very much. And what I'll be just talking about is primarily, initially, I'll be talking about the company for those people who don't know Altitude Angel. And then I'll be talking about a particular element of Altitude Angel, what we call our Arrow technology, and how that is supporting beyond visual line of sight operations. So Altitude Angel, then, we're 8 years old, founded by a gentleman called Richard Parker. He used to work for Microsoft, really knows his technology, all the computer stuff, and very much enjoyed that side of the business. But then also he got started getting into drones and how to fly drones and where to fly drones. And of course, this is where the complications started to evolve. And it's like, as a layman, as a person who hasn't been brought up in this industry, this aviation industry, how do I know where I can or cannot operate a drone? Where is it safe or where is it unsafe to operate a drone? And even if you're within the industry, to go and look at the Air Navigation Order, all through these books and publications, it can be extremely difficult to understand where you should or shouldn't operate a drone. So you just thought, how can I bring technology into this? How can I find a simple way of putting all the information in one place and make it really simple for people to understand where they can operate their drones safely? And that's where it all started back in 2014. He came up with this idea, and we have a drone safety map now, and you can log on that and you can see exactly where you can and cannot operate a drone safely. So from there then, in the last 8 years, we've grown to a company of over 45 employees now, and we'll be growing a lot more. It says there up to 50 in 2022. We're looking to go to probably up to about 70 now in 23. The number of flights we have about 50,000 flights a month being input into what we call our Guardian UTM operating system. So the thing we need to know about this is these are voluntary flights. None of these are mandatory flights. This is the industry trying to encourage safe and correct behaviors. and getting people to submit a flight plan, and then they can be disseminated to the appropriate authorities, and people can understand what is going on in the airspace and understand the issues around them and improve safety. And right from the outset, this company was was always aimed at improving aviation safety. So we can access this drone safety map and all this information in 152 different countries. We have 3 national deployments, but we have one mission, and that is purely to enable equitable and fair access for all airspace users, to enable drone operators, uncrewed aviation, to access the airspace. Now a lot of people treat UTM as in unmanned traffic management. We look at it slightly differently for that. We call it unified traffic management. At the end of the day, we have a single sky which everybody needs to use, everybody wishes to share. So we need to have a look. We need to understand how uncrewed and crewed aviation can access the airspace safely and operate together. We want integration rather than segregation. As I said, today we're going to be focusing on our Arrow technology. The aim of Arrow technology is to enable beyond visual line of sight operations. And for those people who are sort of new to the industry, I'll just give you a quick brief, is that up until now, we had a thing called VLOS operations. That's visual line of sight operations. That meant the drone operator has to be able to see the drone at all times to ensure that the drone isn't creating a hazard to other airspace users and is doing as expected, is operating as expected.
Oh, Philip, sorry to interrupt, but I think we cannot see your screen. We can only see the first slide if you're...
Oh, okay. Right, let me just stop sharing and let me have another go at that. See, this is where I need a techie to come and help me. Right, let me have another go. Okay, so we have then this thing called beyond visual line of sight. So this is the problems with beyond visual line of sight is that basically the drone operator, the pilot, can no longer see the airframe. So we need to be able to make sure that the drone operator, make sure the drone is behaving as expected. And it is no longer, and it is ensuring that the drone is not being hazardous to other airspace users and also to people on the ground. So how do we make sure that happens? How on earth do we enable this? And so obviously you've got to go through your civil aviation authority, your local or your national aviation authority to try and get approvals for these operations to take place. Well, we're finding at the moment, actually, getting permits and planning and approvals for this is extremely difficult. So we're looking at this problem, altitude danger, we're looking at this problem and saying, how do we take some of that stress and problems and issues that drone operators face away from them, and we will try and solve that problem. And this is what we're trying to do with Arrow, with our Arrow technology. So why is it so important then, BVLOS operations? Why is this so significant? Well, quite simply, this title here, that the EU believe by 2030, this is going to generate an industry, just in the EU alone, of 14.5 billion euros and up to 145,000 jobs. So that's a significant volume of a significant market this place is growing. And if we look in the graphic just below that, we can see there we've got logistics. Logistics by far and away the largest opportunity we're seeing, which potentially can use this beyond visual line of sight capability. And since we've set up our Arrow technology and we're setting up this Skyway project, we're having a lot of companies who are going to be following this route, which I'll talk about in a minute, a little bit later, wanting to participate in the corridor. Once they're starting to hear about it, they're getting more and more interested about how they can actually access the corridor and wish to use our Arrow technology. And we're finding initially, we're sort of getting medical logistics. We have a thing called the National Health Service here in the UK. And they are very, very interested in adoption of drones to help with various elements or logistic problems that they have. We have a lot of centralization of pathology labs. We might not have them at every single hospital. So how can we get pathology samples from the hospital to the pathology lab very, very quickly? And as we all know, I think most places in the world are suffering from the same problem. Congestion, road congestion is getting worse and worse and worse. So, but you look up at the sky seems pretty empty. So is this something we can do, like using the sky to help out with logistics? And it's certainly gaining an awful lot of momentum and incredible amounts of interest. So with that, I'm just going to show you a short video. This video is just demonstrates what we're doing here in the UK under our Future Flight Challenge project. Forgive me, this is a promotional video, so I apologize, it comes across as a bit of a sales pitch, but it's the best video we have, and it's the easiest way to actually explain exactly what we're doing.
In the 1800s, the rail network expansion fueled significant industrial growth. Connecting towns and naval ports together brought revolutionary efficiencies to the movement of goods and people, spawning entirely new industries and businesses. Today, we begin the next industrial and commercial revolution: automated flight. The Skyway system establishes a network of superhighways up to 10 kilometers wide, with the first main route spanning 265 kilometers between Reading and Coventry. Soon, time-sensitive transportation of medical items and organs, fire, medical, and police scenarios, as well as the delivery of high-value, low-volume goods, can start to be moved by automated drone, unlocking the vast potential of drones to transform lives and revolutionize business. Skyway has safety and privacy at its core. Powerful sensors on the ground looking up detect crewed and uncrewed aviation traffic and create a real-time moving map of the sky above, which is relayed to the Skyway controller in the cloud, where it is used to provide automated air traffic control for drones flying on the superhighway, preventing collisions. Drones can enter or exit the Skyway anywhere along the route, bringing access to millions of businesses and citizens. Automated flight, anywhere and for everyone. Just imagine.
So there we go. We have a list of some of our partners in this, and I think it's only right that I actually mention them. I think one of the interesting partners is BT. So we're setting up towers, and of course BT has a lot of cellular phone networks. So we're partnering with BT, and they're able to provide cellular network towers in order to deploy the appropriate sensors on board each tower to enable this beyond visual line of sight activities to take place. I'm not sure about other countries of the world, but putting more and more towers up across the countryside, you get a lot of pushback from a lot of communities get a lot of pushback having yet more unsightly towers. So this is where we're trying to utilize the available technology or the available networks we have today. So here we have then this Arrow technology. It's all around deploying the appropriate sensors in order to cover the suitable area. So the corridor is going to be about 8 kilometers wide, and we get customer off-the-shelf products, COTS products, the appropriate sensors and display and correction, put them out across the 155 miles of corridors to enable safe operations of BV loss operations. Now, the clever bit, dare I say, is in the office here, where we've got a lot of very, very clever engineers to bring all of this data together. As you can imagine, all of these sensors on a mast, there's quite a lot of data being thrown around. And these guys are able to bring it all together to provide a single picture of truth. And what it is we need to try and do is having multiple sensors. How do you know whether, if you have 3 sensors picking up an airframe flying through the sky, how do you know whether it's one airframe being picked up by 3 sensors, or is it 3 separate aircraft being picked up by the 3 sensors? And because there's always a time lag with all the information that's coming in, so we need to work all that little clever bit out to make sure we understand exactly what's going on in the airspace, because we need to get this single point of truth to understand that. Now, the way we're dealing with all this is we want to ensure that we enable a low barrier to entry. Now, the purpose of that is it enables us to open up a business case, or enables industry to open up a business case. If you can get the cost of entry as low as possible, then more business opportunities and more use cases can be adopted and adopt this technology. And that's what we're finding with when we're having conversations with industry at the moment. Industry is they don't want to fork out for huge, big, very, very big drones with all the sensors on to be able to detect everything that's going on in the airspace, and to understand that airspace is dynamic and there are changes to the airspace restrictions, closures of airspace. So how is it we can keep that the drone itself relatively simple and focusing on the actual payload itself, delivery of the payload, and we will deal with everything else. Altitude Angel will deal with absolutely everything else going on. So this is the kind of the balance that we need to do when we start dealing with all these kind of bits and pieces. As I said, airspace is dynamic. So as we travel along the airspace, we may get restrictions of airspace suddenly popping up, airspace closures or NOTAMs, which will affect flight. So we have this real-time information is coming in. Guardian UTM will look at it, assess it in relation to a flight plan, and adapt the flight plan accordingly in order to make sure the drone has the shortest and most efficient flight to carry out its activity, its task, its delivery service. And of course, as I said, the lowest, if we can keep the cost down to a low point of entry, it does mean more industry is going to be interested in what's actually going on. So we have these towers set up, but typically, of course, you're never going to get a tower in the right place, or somebody just off the highway, the superhighway, will suddenly want to have access to it, and they're not quite in coverage. So what we've done is we've got a mobile system, our Arrow van, which we have. It's a mobile capability. Now there we have effectively the same sensor array as we would do on a fixed tower. However, the issues we face is on each of these towers, you don't necessarily have the same sensor array, because it all comes down to the complications or the complexity of the airspace or even the topography of the ground. And therefore, we must be able to change the sensors and adapt the sensors to meet the requirements of that bit of airspace. So if you're operating a drone, or we have a superhighway transiting area, a rural area, not small communities, very, very underpopulated area, actually your sensor array probably doesn't have to be as sophisticated as if you wish to have a drone operation taking place in an urban environment, in a city and stuff like this. Because of the safety hazards of operating a drone in that city, you have potential far greater hazard to people on the ground and other people in the sky. So we need to think about those sensor arrays. So we have this mobile solution. But of course, we don't want 20 different sensors on this mobile solution, because one, it gets very, very heavy on the tower. Two, it uses up huge amounts of power. And three, it just makes things a lot more complicated. So when I spoke to the British Army about this, they just said, well, it's kind of a golf bag, isn't it? So this mobile technology is treat it as a golf bag. So if I'm going out to play a game of golf and I say, right, I want to go and hit X number of yards, I delve into my bag, pick out the right club, and hopefully hit that golf ball, and it will go the correct distance. The way I play golf, it probably won't, but to anybody who's quite good at golf, it probably does. And that's how we look at this mobile facility that we've got. We look at the environment we're going to be operating in, the environment the drones are going to be operating in, and then we can work out actually what sensors need to be put on there. And we can effectively plug in, it's all modular, plug on the right kind of sensors, the mask goes up, and we provide the appropriate situational awareness for safe drones operations taking place. Now remember, this is all about integration, not segregation. So that is why this is so important that we get this right. Integration is scalable, and unfortunately segregation is not scalable. So we have this mobile facility that's going on, and as I say, it's taken quite a lot of interest, or it's picked up quite a lot of interest. Now on the left-hand side here, there are a few bullet points. It can be a temporary expansion to the superhighway. As I mentioned, something's just off the superhighway, it's just outside the 8-kilometer wide highway itself. How can we bridge that gap to help that industry out, help that company out? And of course, one of these things can be used. But likewise, we have a site surveying as well. You get a lot of you get a lot of civil engineering work. So I have a big civil engineering project at the moment, HS2 here in the UK. Now they've used drones for a lot of surveying activities. But when we start to go down that route and more civil engineering companies will wish to use drones, we can simply set up one of these things and all of a sudden we can have an 8-kilometer wide area, I suppose, rather than a corridor. We can start establishing areas, and we can maintain a situation awareness for BV loss operations in that area to support something like a site survey or this mobile unit. And also a thing called pop-up UTM. This is an activity that we did a number of years ago, but it can be integrated into our Arrow technology, whereby if you lose, for whatever reason, natural disaster, and you lose all ground networks, you can quite simply set up an Arrow tower and set up a situation awareness and understand what is going on in that airspace out to about 8 kilometers, 5 miles or so. So it can be done as a very temporary measure to fix a hole while you've lost all ground networks, and then we'll use satellite relays, or it can be done from many other elements or industries or whatever. As you say, on the right-hand side, there's a list of benefits that these things bring, which I won't read into now because obviously you guys can actually read that yourself. This sounds all quite easy, but dare I say it, there have been quite a lot of challenges in this. Not first, unsurprisingly, we have challenges around regulation. What we're trying to do is new. It is completely different. There have been other projects around the world who are trying to establish a corridor, whether that's in New York State, and also there's another project in the UK that tries to set up corridors, a beyond visual line of sight corridor. However, what they've done is the way they've approached it, the cost to set that corridor up is absolutely huge. It's vast. And therefore, we're trying to find an affordable way and therefore cost-effective and to enable industry to grow. How can we do that? And there are lots and lots of regulatory challenges there. And because the regulators haven't approached this before, this is all new, they're in fact learning along with us. And so we're asking sort of guidance. We're working very closely with the regulators. And I'll give you a quick example of one of the problems that we have faced today. Firstly, it's using camera equipment. Now, we know camera technology is very good, but anything in our regulations, in our air navigation orders and stuff like that, we need to say the camera is the equivalent of a human eyeball. But there's no calculation to say, hey, the human eyeball is this good, therefore your camera must meet this measurement. It's all about, well, yeah, that's good. Is that right? Isn't that right? So there's a lot of trials that we need to do. We've done that in our test corridor to bring the evidence together to say to the Civil Aviation Authority, here we go. With the cameras, we spotted all of this. With the human eye, we only spotted this. Therefore, can we say that this camera is better than the human eye? And so we have those kind of conversations taking place. Another one is vertical separation. Now, this may sound really bonkers, really, vertical separation. We're already dealing with the first 400 feet at the moment. We're limited beyond visual line of sight. Below 400 feet, we want to keep it out of where crewed aircraft are operating primarily. I know we do get aircraft operating below 400 feet, but the majority are operating above. But vertical separation is a real challenge because today, the way drones operate is they tend to measure the height of their operation from their starting place. So they put their starting elevation as 0.0 and they can operate up to 400 feet above that starting point. But as soon as you start to go beyond visual line of sight, you get many drones operating along 155 miles of corridors. Guess what? Everybody's starting elevation is going to be different. So if everybody's measuring from a different point, how do you know you've got vertical separation as aircraft are passing each other or as drones are passing each other? So that's a real challenge. There's no universal agreement about how we're going to measure vertical separation. We could go down the manned aviation or crewed aviation of using regional pressure settings, and each vertiport has its own pressure setting, just as you get at an airport. And we use QFE, QNH, and those kind of things. But this is still to be decided. Now, at the moment, with the volumes of traffic, the way we have gone around this is to basically treat everything as on the same level. So we'll never go over or above each other. We'll keep everything as basically at the same level. So we'll end up with horizontal separation rather than vertical separation. But to use the airspace effectively, we're going to have to think about this vertical separation and how we're going to crack that. And finally, then, we need to think about then is engagement. Now, there's a lot of excitement around this, that there is a lot of societal benefits. And when we speak about the NHS, when we speak about the police and the fire service using these kind of technologies, people are really engaged in and around this. However, having said that, there's also a lot of question marks around the noise issues, the privacy issues, other airspace users, whether it's the military, emergency service helicopters, so on and so forth. So it's absolutely paramount that we end up in parallel conversations to make sure we bring these people along for them to understand that what we're doing is safe and we're not going to adversely affect them. And these drones don't make the same amount of noise as an A380 or a 777 landing at Heathrow or getting airborne from Heathrow, or a helicopter getting up airborne and stuff like that. The electrification of these aircraft is a lot quieter. But we must demonstrate this. We must prove that this is the case. And so there are lots and lots of local and community engagement to bring them along for them to understand all of this that's going on. So ultimately, this all comes together. What is it we're trying to do? We're trying to enable automated flight. We're trying to help drone operators streamline the process so we'll take the detect and avoid issues and concerns and we'll manage the drones safely going through the airspace. We provide that situation awareness for people to use, that single point of truth to understand everything that's going on in the airspace, then everybody can make an informed decision. And ultimately, what we're trying to do is have on-demand automated flights everywhere. And so far, this has gained a huge amounts of interest, not just here in the UK, but in many, many regions around the world. So we're really, really excited about how this goes on. And hopefully, well, in the next 18 months, we'll have 155 miles of it in the UK. And hopefully that will quickly spread to other regions of the world. Okay, that's all I have for that. There are contact details. I'll stop sharing so you can see me, because I don't know if you can see me or not. And if there are any questions, I'm open to questions. Please feel free to ask.
Yes. Thank you, Philip, first of all, very much for this wonderful explanation of the technology and the Arrow project. So we have questions coming in. One question we have is, I'll read it out to you. Does Arrow support satellite connectivity to complement the mobile network connectivity to create redundant connectivity to ensure seamless communication? Yeah,
absolutely. We can do that. We've done some work with satellite technology already. We did this thing called pop-up UTM, where we did activity in Turkey, where we had a drone operating, I think it's 80 kilometers away from Ankara. So the ground control station was in Ankara. We had the temporary restricted area about 80 kilometers away, where we had drones operating in there. And then we broadcast it all back to the UK in Reading, where our head office is, so we could see everything. So the key to this is, yeah, we've got that satellite technology. We worked with Inmarsat for that one, and Atexin, and we demonstrated how that could work. And we wanted to provide that demonstration really for natural hazard areas, natural disaster areas, I should say. When you've got no ground cover at all your ground networks have gone, how can we enable crewed and uncrewed aircraft to operate in the same bit of airspace, providing this complete situation awareness of what's going on? And this is how we just demonstrated. So satellite technology, absolutely, it really is the key to moving forward with beyond visual line of sight, especially in those remote areas.
Thank you, Philip. We have another question from Gary. Gary's asking, will general aviation and model aircraft flyers be affected by this, by the superhighways? Would there be a cost or restriction for hobby flyers?
Absolutely not. So that is one of the most important things. So when we're talking and putting this project together, here in the UK, what we had was, in order to allow beyond visual line of sight operations to take place, they had to take place in segregated airspace. So that could be in a temporary danger area, or it could be, a temporary danger area could be set up, or temporary restricted areas, something like that. And of course, straight away, current airspace users get affected by that. They can no longer access that airspace, and quite rightly, they get frustrated. So what we have done now is this Arrow corridor is in non-segregated airspace. Uncrewed aircraft that require service from us must be registered with us, submit a flight plan with us, and they'll go down the corridor. Anything else can zigzag through the corridor. But all we'll do is those towers have the appropriate sensors on to detect what's going on around, and we'll track and monitor all the non-participating aircraft, and we will turn the uncrewed aircraft around and avoid what is currently going on that airspace. So the whole purpose of it is this safe integration and not to have segregation, because segregation isn't scalable and it really frustrates current airspace users.
Right. Thank you again, Gary, for that. Sorry, Philip, for that. We have a question. Is the superhighway in the Class G airspace only?
Is largely...
is the superhighway in the Class G airspace?
Class G airspace, my apologies. Absolutely, that's where we're focusing on at the moment. The reason why we're focusing on at the moment is that is the toughest nut to crack. Class G airspace, for want of a better term, is bandit country. You can get airborne. You don't need a radio in your aircraft. Get airborne. You don't have to inform anybody, and off you do is go flying. So how do you've got all this random activity taking place? How do you enable beyond visual line of sight operations to take place? So it is the hardest airspace to manage, because there's hardest airspace to enable beyond visual line of sight operations. But if you can do it in Class G airspace, it becomes far easier in other classes of airspace when there's an element of airspace management taking place. So yes, Class G is what this was all about, to enable routine BVLOS operations.
Yep. Thank you again. Another question we have: do you have any APIs available for integrating the UTM directly to cloud-based remote operation software?
Yes, we do. We use our APIs. We publish our APIs on our website for people to go in and have a look and see where they can use it. There is one API that we don't publish at the moment, but it's only the one, and that may be, I'd have to ask our engineers, our team of engineers, exactly which APIs we don't. But I think if you wish to access Arrow as part of the project or Skyway, we would need to speak to the program manager and our engineers to enable that. But once it's up and running, then it'll be an open API to interface with us, and we can activate. They can access it very much so.
Right. We have another question from Gary. Do you need infrastructure owners such as cell phone towers to roll this out, or will it all be your own infrastructure?
No, this is why we're working with BT in the UK. So we're trying to use existing infrastructure. We don't want to establish loads and loads of new towers. It just, you get huge amounts of pushback from local communities to have yet another tower and stuff like this. So working with BT, I think they have over 10,000 cellular towers across the UK, and we'll use those wherever possible. However, we have to accept the fact there will be the odd tower requirements and new towers that will be required to establish these superhighways. There's nothing we can really do about that, and that purely comes down to the topography of the land, the shape of the land, to make sure we have the right coverage in order to ensure, or to make sure everything is maintained, everything is safe and safely integrated into the airspace.
Right. Are you integrated with any docking stations, and how can someone leverage the Arrow technology and Audit Angel's platform for BVLOS waivers?
Docking station, as in, I'm assuming that means a vertiport, a drone vertiport and stuff like that.
Yes.
What we're doing is at the moment, as the very, very start of this project, we do have a number of activities or a number of operators who are going from hospital to hospital. So as I said earlier on, we're finding the NHS is very, very keen to get involved. So they will operate from their helipad at the hospital. So that can be effectively a vertiport or something along those kind of lines. There is no reason why a vertiport can't link into these networks. And even if they're off the network, as I say, we could, if there's a vertiport, you could probably set up an additional Arrow tower to bridge the gap and stuff like this. Or we can, as a temporary measure, we could put a mobile tower in there. So yes, we are in conversations with people, but if people are interested in finding out a little bit more how they can get involved, we'd be more than happy to have those conversations without a shadow of a doubt. It'd be fantastic to have further conversations with vertiport developers, manufacturers, or anything along those lines to see how this can grow.
Right. There's one question. So are there any physical infrastructure required other than the towers or the mobile towers that you deploy? Are there any additional physical infrastructures that would be required to deploy this?
No, well, the infrastructure there's a communications network that's required, and that's why teaming up with BT again, they have that infrastructure, communications infrastructure network. So working with cellular phone companies, again, we're utilizing a network that is already there, so we don't have to set up our own networks. So that is what we're doing at the moment. And yeah, and we're noticing with conversations in other regions of the world that the cellular phone companies or telecom companies are very, very interested, because they just see it as another way of exploiting their assets that they have already and not having to build separate and new networks. And remember, if we start building new networks, as I said, there are other regions of the world who've started everything from scratch. And wow, the cost is phenomenal, absolutely huge. So why would we go down that route? Why not partner and utilize what's there already?
Right. That helps, Philip. And one last question that we have is, are you planning to expand in other countries? Currently, you have this focus in the UK for the superhighway, but are there any plans to do this any overseas or other countries?
In short, yes, there are. Absolutely, we are. We are talking to a number of other countries at the moment. Unfortunately, I can't talk about those. They're commercial agreements that are coming to play, and I don't know what I can and cannot say about those. So I'd rather not. As I say, so the project here in the UK is all around, is based on a government-funded or part-funded government thing called Future Flight Challenge. And therefore, that's why we are UK focused at the moment. Having said that, though, we are in conversations with other countries about how we can utilize this technology overseas. So it's quite an exciting time. It really is, and it's more and more interest in this kind of technology.
Right. So yes, Philip, again, thank you very much for this very insightful session. Would you like to share any closing thoughts?
Well, really, if people are interested to find out more about it or to participate or be kept up to date, please get in touch with Altitude Angel. Ideally, we have an email address previously showed up, but very, very quickly flashed up. It's basically hello@altitudeangel.com. If you have any questions or like to find out how we participate or anything around beyond visual line of sight or anything else that we do, we're more than happy to have a conversation with you guys. Look, we see this as really providing fantastic societal benefits. Whether that is in a developing country or a developed country, the benefits of having BV loss operations are absolutely incredible. And I did lucky enough to go over to Rwanda about 3 years ago, and to see how BV loss operations are supporting medical activities out there, and it's absolutely fantastic to see. If we can grow that, the benefits to, as I say, to all regions of the world will be absolutely outstanding, and it's something that we're really, really keen to get on and really push for. So please, any questions, don't hesitate to get a hold of us. We'd be more happy to answer those questions. And really, thank you very much for inviting me to come along today to speak. And I hope this has been informative for everybody who's listening in.
Right. Thank you very much, Philip. It was a really insightful session. I am keeping on saying it because I learned a lot about the superhighway and all the technology. So yes, thank you very much for your time, and thank you everyone for joining. Hope you are having a great time at NestGen, and coming up in the next few minutes are more sessions. So request everyone to go to the sessions tab and attend the session of their own choice. See you in the next session. Thank you, Philip. Have a good day.